Today we will be looking at resistance and Ohm's law. First, what is a resistor? A resistor is a special circuit element often made from metal or carbon that has the same resistance value no matter how much current flows through it. To find the resistance, we can use the formula R equals to delta V divided by I, or take the slope of a voltage current graph. For example, here we have a very simple circuit. We have a cell connected to a 10 ohm resistor and an ammeter with a voltmeter measuring across the cell. We will change the voltage of the cell and see how the current and voltage changes. Next, we will graph this data in a voltage current graph. As we can see, the slope of this graph tells us the resistance of this resistor is 10 ohms. And we can see that the resistance is constant because the slope remains constant throughout the graph. This tells us the resistor is an ohmic resistor, meaning that it obeys Ohm's law, which states that the current flowing through an element is proportional to the delta V, represented by the equation delta V equals to I times R. Next, we look at resistors connected in series and in parallel, and how to find out what their equivalent resistance is. Equivalent resistance means that the resistance of one resistor can replace a network of resistors connected in either series or in parallel. First, we look at three resistors of 3 ohms each, connected in series to a 9-volt battery. If we measure the current going through the battery, we can see that's 1 amp. Using the formula R equals to delta V divided by I, we can find the resistance of the circuit is 9 ohms, which is the sum of all the individual resistance of the resistors. From this, we can find the formula to find the equivalent resistance of resistors connected in series to be R equivalent is equal to R1 plus R2 plus ... Rn. Next, we have the same 3 ohm resistors in a 9-volt battery, except now they are connected in parallel. Let's take the measurements. The current is 6 amps. Using the formula R equals to delta V divided by I, we can calculate that the equivalent resistance must be 3 divided by 2 ohms. From this, we can find the formula of equivalent resistance of a parallel network to be 1 divided by R equivalent is equal to 1 divided by R1 plus 1 divided by R2 plus ... 1 divided by Rn.